Today we are going to solve Pearson Edexcel International GCSE 91, okay? Monday, 16 June 2025, the most latest paper of physics, 4PH1 with 2P physics, okay? 4PH1 unit, all right, paper 2P, okay? Today the paper is 2P and total marks for this paper is 70 marks over there. Before starting the solution, I will request you kindly subscribe my channel and like and share the video with your friends and try to focus the solution style and try to use the formulas properly which are already given you in the form of insert. Okay. And I try to mostly solve the latest papers. So it will be very helpful for you. For all sciences and mathematics, it will be done. Chemistry, physics, biology, and mathematics like that. Okay, a student plays a game using a single dice. All right. The student decides to determine the density of the disk by measuring its mass and volume. Because we know density has the formula. Density has the formula mass over volume. So it will be used for measuring the density of the dice over there. Before starting, let's go to what he is saying properly. Describe how the student could accurately measure the mass of the disk. So for measuring the mass, the point which I will highlight that the student should use electronic balance because he will easily measure the mass in grams like that, and he can easily use using the electronic balance, and he has given for 2 mass. So we will also use other precautionary measures for the exact value over there. He should level the balance should be zeroed in the start, and the volume should be and leveled, so that when you put the dice over it, he can give you the exact value over there. The disk is not regular shape. The student decides to measure the volume of the disk using a displacement method. The student um, places the dice into a measuring cylinder containing water. Okay, the diagram below shows the water in the measuring cylinder before and after the dice is submerged over there, fully submerged over there. Okay, from here he is saying that the level is 30, and here the level is, if I'm taking like this form, 30, 31, 32, 33, 34, 35. No, it is 32, 36, 4, 36, 37. So if I take the volume from here, then I will say this is my initial reading, volume initial, and this is volume final. For getting the change in volume over there, the volume of the disk, I will say here V final minus V initial. Then the volume will be calculated as 37 minus 30, and you will get the value 7 cm cube should be taken as volume over there. 7 cm cube. The measuring cylinder in centimeter square, you know, determine the volume of the disk. We have calculated that. That is 7 centimeter cube. The disk has mass 9.2 gram. Calculate the density with its unit also. Okay. So mass is 9.2 divided by 7. So I will say here fraction introduced 9.2 divided by 7 is equal to, this is equal to 1.31. 1.31 gram per cm cube over there. I have not taken in kilogram per meter cube or like that. So you should also try to focus over there. It was the easiest method to get the chef because he said that dice was not properly short edged over there, and the volume should be taken on the basis of the volume change of water when it was totally submerged. Okay, let's move to the next question. This question is about sound waves. Which range of frequency of sound waves can be heard by humans? From 20 hertz to 20,000 hertz. This is the constant value, audible frequency range. Audible frequency range for human over there. All right, the table gives some statements about the sound waves. Okay, sound waves are longitudinal waves. He is correct. Sound waves can travel through a vacuum. No. Okay, sound waves are part of the electromagnetic spectrum. Sound waves are part of the electromagnetic spectrum. I don't think so that it should be taken. No, it should not be the part, because in electromagnetic spectrum, we know that they start from radio waves and end up with gamma rays like that. They don't have the sound waves over there. Sound waves can be reflected and reflected, yes, and it is true. Why it is reflected? It gives the echo, and refracted, that they can change their direction a little bit if they are provided some diffraction or some refraction phenomenon over there. An oscilloscope can be used to display a sound wave. Give the name of the variable that is measured on the x-axis of the timetable screen over there. Then on x-axis, remember that there will be time always. And on y-axis, it can be taken according to amplitude. It can be taken according to speed, like that. That can be taken. Okay. Here in the next part, he is saying the diagram shows on the trace of a table. Okay. On the screen, draw the trace of the quieter sound wave with lower frequency. So I will say here that I will take it is one wave complete and two wave completes. So I will say here low frequency and quieter sound with lower frequency. Quieter sound means its amplitude are also decreased over there. Amplitude is also decreased. So I will say here I am going to draw like this and draw like this and this. So I will say here that try to make the sound wave with the lower frequency, that the number of cycles according to time period should be decreased, and amplitude is also decreased, that its height is from exactly 1.5 to approximately 0.9 and 0.9 I have taken in both of these cases. So it is quieter sound and it is having lower frequency as compared to its original one. Okay, in the next question, let's see what he is saying over here. The photograph shows camper, okay, van with a solar panel on its roof. The solar panel is made from lots of solar cells connected together. Okay. The solar panel is connected to battery, and the solar panel receives the energy from the sun to charge the battery. Describe how energy is transferred from the sun's energy store to the battery energy store. So I will say here that nuclear radiations coming from sun are going to be taken by the battery over there. So I will say here energy is transferred. Energy is from sun, transferred from sun by radiation, from sun by radiation method to the solar panel over there, to the solar panel. And after the when solar panel has absorbed the energy over there, then energy is absorbed by solar panel. When it is absorbed, then we can say that energy will be transferred from panel to battery for electricity, and energy is transferred to battery from solar panel over there. And in all of these cases, we can say that it increases basically, and when battery is going to absorb, and chemical energy of battery, chemically energy of battery is increased. So this was your whole concept, how the solar radiations are giving you we can say solar energy is given in the form of radiations absorbed by solar panels and converted into electrical energy in the form of battery. Chemical energy is increased over there. After that, he is saying for 1 mark, the petrol engine can be used to charge the battery of the camper and give an advantage using a solar panel instead of petrol engine to charge the battery. Don't refer to the cost in your answer. So I will say here that the main benefit, I will say solar energy is renewable. This is the main benefit. It is coming again and again. And I will also say that the solar panels don't produce carbon dioxide or pollution over there. This is the second benefit. I can also hear that even though we know that petrol will run out, but solar energy will not run out, you can also add in the form of non-renewable source over there. The surface of solar panel is black. Explain why black is suitable color for the solar panel. Because black is a good absorber of radiation. Because black color is good absorber of radiations over there. And we can say here that if it is a good absorber, then it is also a good emitter also. But solar panel will be getting heat at very faster rate, and much more electricity can be produced over there. After that, what is he saying over there? He is saying the solar panel charge the battery in a camper over there with a maximum current of 15 ampere. Okay. Calculate the minimum time to transfer 36,000 coulomb charge through the battery. Use the formula charge is equal to current multiplied time over there. And I want to calculate minimum time. Make time as a subject. Time is equal to charge over current. Then charge is 360 with 1, 2, 3 divided by 15. Then I will say here it will be 360 with 1, 2, 3 divided by 15 equals to 24,000 seconds over there. So it is giving us the value of 24,000 seconds. So this is the way how to manipulate these formulas. Mostly formulas will be given. Just place the data and simplify them. Okay, in question number 4, he is saying here the photograph shows a mechanism that can be used to open a gate. Okay, by spring and locked and touch them, push and gate. All right, this is spring system which is given over there for the proper lock of the gate. The diagram shows the gate mechanism when the handle is being pulled to the right over there. Okay, 70 centimeter, 22 centimeter pivot is here, and it is force is applied at 70 centimeter, and the pivot is connected to a spring body with the 20 centimeter. All right, the bolt is connected to the handle. Bolt is connected to the handle. Okay, bolt is connected to the handle over there, and when the handle is pulled to the right, the bolt moves also to the right and gate can be opened. The spring is compressed and the bolt moves with the right. When the handle is released, the spring pushes and okay, all right, to the original position due to restoring force over there. When a handle is pulled to the right, the spring applies a force on the handle to the left. The vertical distance between the spring and the pivot is 22 centimeter, and the force from the spring is 5.2 Newton. Show that the force from the spring produces the moment approximately 1 Newton meter. So I can say here that we will have to take the moment formula, moment or torque, as the value of force multiplied distance or perpendicular distance over there. That is also a vector quantity over there. Then we will have to take 5.2 multiply 22 centimeters should be changed with the into meters. Then it is 0.22 meter over there. So 5.2 multiply 0.22. 5.2 multiply 0.22. So it should be given like this. It should be given 1.14, which is equal to 1.14. He said approximately equal to this. So we can say it is approximately 1 Newton meter over there. Okay. State what is meant by the term principle of moments. Then we can say here that the sum of clockwise and anti-clockwise moments will always be equal. Sum of clockwise and anti-clockwise movement will always be equal to zero. Equal to zero at equilibrium position. So this was a little bit just like a definition in which we can say, let's suppose this is a rod, this is the pivot. Here it is clockwise movement and anti-clockwise movement. And if this rod is balanced over this pivot and the clockwise and anti-clockwise movements are equal, then we can say they should be being taken as their whole value over there. Okay, now he is saying here the force Fx on the handle to keep the handle stationary so that the gate can be opened. Force Fx vertically at a distance of 70 centimeter from the pivot of the handle. Calculate the magnitude of the force F. So I will have the value of my moment is 1.14. 1.14 as the torque moment is equal to force multiply 70 should be taken as 0.7. It should be converted into 0.7 meters over there. So F is equal to 1.14 divided by 0.7, and let's go with it. 1.14 is already given. Okay, divided by 0.7 equals to this equals to 1.63. 1.63 Newton is the force which is produced. 1.63 Newton. Give two changes to this gate mechanism, what would make it easier to open the gate over there? All right, it is easy. How it we can make it? Make the handle of longer length, then you can easily open it over there, and you can also we can say weaker the spring over there, and you can easily get how the gate should be opened over there. Let's move to question number 5. Here he is saying, okay, uh, a student uses this apparatus to investigate the static electricity. A positively charged ball is suspended vertically a long length of the string over there, not to scale. Okay, this is positively charged. All right. Then what to do? The ball is made up of material that is a good electrical conductor. Name the material that is good electrical conductor. That can be metal, because metal has the free electrons over there, which are responsible for electrical conductor material. Free electrons are carried out by metals, so that we can say they can easily transfer the electricity over there. Explain in terms of the movement of charged particles how the ball has become positively charged. So we will say when a neutral body transfers its negatively charged electrons to the other body, then we can say it is positively charged. And when a metal, when a neutral body transfers its negatively charged electrons to the other body, and then the body becomes positively charged over there. So this is the way how we should go towards static electricity for any body which is positively charged over there. Okay, here he is saying the student places a centimeter scale behind the length of a string. Okay. The string lines up to 5 centimeter mark on the scale. Okay, this is the 5 centimeter mark. When the ball is in the resting position as shown in figure, what will happen? That positively charged ball is there. The student brings a negatively charged polythene rod near to the right side of the ball. The ball moves as shown, means it has moved towards this. This is negatively charged polythene rod over there. Explain how the movement of the ball shows that the charge on the polythene rod is negative. Means as we know, the ball is positively charged and ball has moved towards a rod, which means that rod is oppositely charged, and it means a rod is oppositely charged, which means that they are showing the force of attraction. As we know, unlike charges attract each other. Unlike charges attract each other, like positive, negative, negative, positive, shows the attraction over there. So here he is saying in the diagram the string lines up with 7.2 centimeter mark on the scale. The student moves the polythene rod slightly further away from the ball. Predict the possible reading on the scale. Now you should remember that you have moved it little bit far away towards the right, then definitely force of attraction will decrease and your reading can be from the center value 5 to 7.2. You can write any number. Let's suppose I'm writing here 5.5 centimeter. That is the reading of that scale, which when you have removed your rod over there. Or you have taken your rod little bit away from the man point over there. Okay. Now he is saying move towards part D, where he is saying the student extends the investigation by measuring the reading on the scale for rods made from different materials. A control variable. The student charges each rod by rubbing it and with the cloth with the same number of times over there. Give two control variables the student could investigate over there. So here we can say he can investigate initial charge on the wall, initial charge on ball. He can investigate that. Initial charge on the ball, he can easily investigate from here, and he can investigate the dimensions of the rod. Of rod over there, and he can also take distance between rod and ball. So this was our easily explained value over there. Okay, here he is saying the bar chart shows the result of the student's investigation, readings on scale in centimeter, ebonite, glass, nylon, polythene, wood over there. Justify the use of bar chart to present the student's result over there. So here I will say that he has used the rods made up of different materials. So he will say that the material is the material with which the rods are made up of, the materials is a categoric variable. Categoric variable over there. Okay. In number two, is saying deduce what can be concluded about the charge on each of the rod used in this investigation. We can simply say here that it is exactly 5 centimeter means wood has no charge. We can say wood has no charge. Number 1 point which I am highlighting here, wood has no charge. Why I said so? If you observe above, you can see that it is 5 centimeter, it is wood, and it is exactly at 5 centimeter. It is not showing any little bit increase or decrease into the force of attraction or repulsion over there. So we will say wood has no charge. And after that, I can say ebonite and polythene. If I talk about both of them, then I will say they will have the negative charge because ball is attracted towards them. Ebonite and polythene have ebonite and polythene ebonite person both have negative charge over them, so they are attracted towards that rod. Towards the ball is attracted towards them, and they have increased the distance from 5 to 6 or 7 centimeter over there. I can also say gas and nylon are positively charged. What can I say? I can say here glass, and the other one was glass and nylon have positive charge because the repulsion has happened over there and the object is moved towards the main carrier over there where I have written this. Guys, you can take this for the below part, okay? For this part over there. Okay, what he is saying in the next question over there. The question is about gamma radiation. All right. Gamma radiation means which moves with the speed of light over there. And he is saying which statement is correct about for gamma radiation. Gamma radiation has weaker penetrating power. No, because they have don't no charge, so they have the highest penetration power. Gamma radiation is emitted by electrons and atoms. No. Gamma radiations is positively charged. No, they have no charge. Gamma radiations is less ionizing than alpha. Definitely, because when they have no charge, they will not producing any type of ionization in their structure over there. A student uses the simulation investigation gamma radiations. This is the student's method. Place a gigamolar tube, distance of 6 centimeter, and a source of gamma radiation. Measure of the count of for a time of 10 seconds over there, and move the gigamolar tube further away from the source and measure the count again. The student measures the count 3 times of each distance. Give the reason why the student takes the repeat readings. So I will say here that to reduce the random error, reduce the random error, which happens mostly due to repetition of the experiment over there, and to reduce the random error, and he takes the mean to get average value over there. Okay, what is he saying in second part? He's saying the graph shows the student's result 14,000 and then 7,000. Okay, it is a half-life question like that, I think so. Let's move towards it. The student claims that the data obeys the formula count multiplied distance square is equal to constant. Evaluate the student's claim over there. So I can take it in the form of proper readings little bit. When this is equal to 5, so it is 5.6. If I show you here, it is 6. Yeah, it is 6. So here I can write a table over there where I'm saying get the count, get the distance, and get the constant over there. So for this purpose, first of all, how many the readings are there? 8, 9, 10, 11, 12, 13. So I'm saying here it is 13,606. These are the values of the counts and distance. So it is count and it is saying the distance over there, and I will use both of these values by putting them into the formula. Then I can get my constant value over there. And remember that if we have the calculation of one constant from the point to the curve, then the calculation of the second constant from the second point on the curve I can get the different values over there. So for the next one, I'm saying go for number 12. 330, 200. So I will say here that it should be going towards 32, 3300. For 12, it is 12, it is 3200 or 3300. Let's suppose it is taken for 12 as its value. So if I go for its calculation of this constant, I was given the formula with uh, 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 with the formula. I was given with the formula. So multiply distance square over there. That is equal to constant over there. All right. So for this one, I will say count is 13,600 multiply 6 square. 13,600 multiply 6 square. 13,600 multiply 6 square. 489600. 489600. This is the value. Then you put 3200 divided multiplied by the value was, what was the value for 3200? That was 12. 12 square. 3200 multiplied 12 square. 3200 multiply 12 square equals to 460800. 460800. Then we can say these are the constant values which we will have to summarize them little bit for getting our final answers over there. Okay. Here he is saying the question is about transformer. The diagram shows here it is primary coil, means these are the number of turns of the primary, and this is your VP. And on the other hand, he is saying the secondary coil, then it will be NS, and V out is equal to VS over there. Then here he is saying that different values of input, output, number of turns in primary, secondary is given. Okay, what we will have to be asked over there, state the formula linking the input and output variables of the values, input primary voltage, output secondary voltage, and the turn ratio over there. Remember that voltage of the primary over voltage of the secondary is equal to NP over NS will be taken over there. NP, NS, number of turns in primary, secondary, voltage in primary and secondary is using this formula. Use the data from the table to calculate the output of secondary voltage of the transformer. For output voltage of the transformer, what we have? We have NP input and we don't have VP. And we want to calculate the VP over there and as VS over there. So NP over NS is equal to VP over VS. So from here, VS is equal to VPNS over VS I need now. VPNS over NP. Put all of these values over here. VP, input primary voltage 230. Multiply NS, number of turns in the secondary coil 300. Over NP, number of turns in primary 1000. So 1010, second zero with second zero, third zero with third zero. So it should be gone with means 23 multiplied by 23 multiplied by 3, 3, 3 the 9 and 6. So it is 69 volt across the secondary over there. So it is 65 now. 69 over there. The transformer is not 100% efficient. Okay. The efficiency of a transformer can be calculated using the formula efficiency useful output over total input multiplied by 100. Calculate the efficiency of the transformer. So P is equal to VI means power in primary and power in secondary should be taken into account. Now you have both the voltages also, and you can manipulate your formulas of transformer can be easily taken over there. If I go for input power, then we can say here that input power should be taken as VI, and power in primary, I need the current in the primary, that is 1.3. Okay. VP is 230 multiply 1.3. That is your input power, where I can say 230 multiply 1.3. What it is? 230 multiplied by 1.3 is equal to 299 is the watt power for primary. After that, this is the power formula for that one. Now go for the secondary power, like output power over there. Then we will have to take as output. We know that the voltage was 69 volt. That is the voltage. And for that one, we are taking our voltage in the form of power is equal to IR like that. Then it should be multiplied by 4 over there. And 69 multiplied by 4. 69 multiplied by 4 over there is equal to 276. So we can say here that 276 divided by 299 multiply by 100 will give you percentage like that. So percentage percentage efficiency of the transformer can be calculated as output over input multiplied by 100 over there should be taken into account. Okay. Explain how the transformers are used in the efficient large-scale transmission of the electrical energy. You may draw the diagram to help your answer if you want. Means we can say step-up transformer are used before transformation. Step-up transformer is used before step-up transformer is used. Step-up transformer is used before transmission. This is the transformers benefit over the other ways over there. So we can say here current is reduced before transmission, and current by using the transformer, current is reduced like that. They can be taken, and voltage is decreased by transmission, and current losses can be decreased over there. That phenomenon is easily explained in my lecture videos. You can consult them and you will get your final answer for this one. And also step down transformer used for transmission line, less energy wasted, and less heating is transferred into wires and cables over there, and less heating transmission wires and cables. After that, we can say current is reduced before the transmission line, and voltage is decreased after the transmission lines, and voltage is decreased and voltage is decreased after. So it was related to your electricity question, which was related to transformer over there. Let's move what he is saying in the next one section over there. He is saying what? The question about cosmology. Give two pieces of advance to Big Bang theory. So for Big Bang theory, I will say a red shift of galaxy, a red shift of galaxy, which shows that the stars are moving away, universe is expanding according to Big Bang theory over there. And I can say here means cosmic microwave background radiations are available. Cosmic microwave background radiation background radiation over there. So this is the way how to go with it. Okay, in the last here, he is saying that second last question maybe. The galaxy NGC 300 is moving away from the Earth at the speed of this. Okay, very high speed. The hydrogen atom in the NG 300 emit the light with a reference wavelength of this. Calculate the wavelength of this light when it is detected at Earth. Give your answer, investigator. Okay, speed of light is also given over there. For that purpose, I will say here use the relation of Doppler shift formula over there that can be taken as lambda minus lambda naught, lambda minus lambda naught over lambda naught is equal to V over C, where V is speed of object through material, C is the speed of light over there, and other phenomena can be taken into account. So for using this formula, I will simply say here, I want to calculate this lambda over here. Put the values lambda minus lambda naught is given in the form of the value 4.3405. 3405. Lambda minus 4 point cc speed of light, and it is 4.3405 multiply 10 raised to power minus 7. Okay, if I make this lambda as a subject, then I will say that you will get the value 4.3, and lambda is equal to 4.3 multiplied 10 raised to power, we can say minus 7 meters will be taken into account. Okay, another galaxy centrus will have Centaurus A is much further away from the Earth than NGC 300. Explain how the wavelength of light detected from hydrogen atom in the Centaurus A is different from the wavelength of light detected by the hydrogen atoms in NGC. So I will say here that Centaurus A will have the greater redshift. Centaurus A the Centaurus A will have a greater redshift, in which I can say so the wavelength from Centaurus will be longer. So the wavelength of wavelength of Centaurus Centaurus will be larger or will be longer. Be larger. So this was your whole paper, which we had to complete in time, and we have done this. In the next video, we will start connecting, and easily will be available on YouTube and Facebook. Thank you so much for today.